Early automobiles were started manually using a hand crank. That changed in 1912 when every Cadillac came equipped with an electric starter. The inventor of this system was Charles Kettering. In this video, we'll explore modern starter through masterpieces of engineering. I'm Yasin, and welcome to the Animatac channel. The starter has a small gear called a pinion that engages with the flywheel. The starter motor spins at high speed, but doesn't have enough torque to start the engine on its own. That's why the pinion gear is about 14 times smaller than the flywheel, to multiply the torque by roughly 14 times. Let's take a closer look inside the motor. Even with the torque boost from the pinion and flywheel, it is still not enough to start the engine. That's why planetary gear system is used inside the motor. This type of gear system is used because it's compact. It not only reduces speed but also increases torque by a factor of 6. Spinning the engine requires a lot of electrical power. In fact, when you turn the key, the starter motor becomes the biggest power consumer in the entire car. Transferring that much electrical power requires a thick cable, and the thickest cable in the car runs from the battery to the starter. To avoid needing a large switch with thick connectors inside the cabin, a small ignition switch sends a signal to the solenoid, which acts as a second high-power switch. At the back of the solenoid, there are 3 terminals. One terminal receives power directly from the battery, another connects to the starter motor, and the small third terminal is the one that receives the signal from the ignition switch. The solenoid is a coil that creates a magnetic field when energized, pulling a piston inside. At the end of the solenoid, there is a contact button that gets pressed by the piston, allowing current to flow through a thick copper connector to the motor. The clicking sound you hear when you first turn the key is the piston inside the solenoid slamming into its end. The pinion is pushed forward by a fork connected to the solenoid piston, and it returns once you release the key. The teeth on the front of the pinion are beveled to help them slide smoothly into the flywheel. Another feature that helps the pinion engage smoothly with the flywheel is the helical grooves on the shaft that carries the pinion. As the pinion moves forward, these grooves cause it to rotate gently and slowly. And now, solving another challenge, the one-way clutch. This clutch is designed to prevent reverse motion from the engine once it starts running from transferring back to the start. This clutch consists of an outer shell connected to the pinion, and it engages with the inner ring, which is the motor shaft, through a set of rollers. When the starter motor spins the pinion shaft, the rollers grip tightly through friction and transfer the rotation to the pinion. But when the flywheel tries to spin the pinion in reverse, the rollers slip, preventing the motion from being transferred back to the shaft.